Okay, this is one of my favorite videos to do. It's on implicit differentiation. And so I'm going to discuss what implicit differentiation is and go right to some practice problems because that's the quickest way to do it. Okay? A function that is written in the form y equals f of x is defined explicitly, meaning the x's and the y's are separated by an equal signs. Like you'd have y equals something x. Okay, that's explicitly. All right. A function that is not written in that form is called implicitly. All right. So let's look at what implicit is. So an easy way to say that, say your x's and your y's are mixed. So below here I have a few examples of implicit functions. The first one is x squared plus y squared equals 1, which is a unit circle. And you could write this as y squared equals 1 minus x squared and then take the square root of both, but then you'd have to do a plus minus, and it's not really a function, but you could write it like this. But for the most part, in the form that it's written right here, this is implicit because the x's and y's are mixed on the same side. Another one here is, see how I have the cosine of xy right here? Equals 2y plus 3, so they're kind of mixed here. Here I have x squared minus y cubed together on one side equals 2x. Then I have x squared plus xy equals 5. So it does look a little bit different when you see implicit functions. So when we do implicit differentiation, I have the steps right here, and they're probably not going to make a lot of sense until we practice it. But you're going to differentiate both sides of the equation with respect to x. Okay? So you're going to do dx. Okay? Treating y as a differentiable function of x. So we're going to be actually doing the formula, because we use y prime or f prime of x. You'll see it this way. Which means, remember, dy dx. So this is the form you're going to be using for implicit differentiation, is dy over dx. Then you're going to collect the terms with dy dx on one side of the equation because you're solving for the derivative, and then you're going to solve for the dy dx. Now I'm going to go through here. Now there's a method to my madness, so do it the way I show you, because later on when we do related rates we will be using this method. So first of all, we're going to find the derivative here. So when you go to do this, this is the power rule and this is a power rule. So the only difference is you're going to tell me with respect to what derivative you're doing it. So I'm going to do, this is the derivative of this is 2x, but it's dx because it's a derivative with respect to x. And then plus, if I do the derivative of y squared, that's 2y, and it's a derivative with respect to y, the derivative of y. And the derivative of 1 is 0. Okay? Then after you do that, what I want you to do is to then go through and divide each term by dx, because you're doing the derivative with respect to x. So here's a term here, just so you see, this whole thing is a term. Divide just the dx by dx. I have a whole term right here, and you can divide the dy by dx. Okay? Now, basically, you're going to be solving for dy dx. That's what you're going to actually be solving for. Okay, so if you'll notice, dx divided by dx is 1. So I really have here 2x plus 2y dy dx equals 0. Okay, now we're going to try to solve for this. So this is a term right here. So what I'm going to do is take and move this 2x over to the other side. So I'm just going to subtract 2x from both sides. So now I have 2y dy dx equals a negative 2x. Now I just want to solve for dy dx, so I'm going to divide both sides by 2y. So I have dy dx equals negative 2x divided by 2y. The 2's will cancel out, so it's negative x over y. So that is my derivative. It's negative x over y. So there's an example of implicit differentiation with the unit circle. Okay, so let's try another one here. So remember, whatever you take the derivative with, you put d whatever that is. So I got 2x dx, okay, minus 3y squared dy equals 2 dx. So I took the derivative dx, the derivative dy, the derivative dx. Now go through and divide everything by dx. So this cancels out and this cancels out. So now I have 2x minus 3y squared dy dx equals 2. Now again, we're solving for dy dx. This is what we're looking to isolate right here. So let's go through and subtract the 2x. So I have a negative, well actually, you know what we'll do? How about we just move this over on this side and move the 2 over here, so then that's not negative anymore. So now I have 2x minus 2 equals 3y squared dy dx, because it doesn't matter, I just still want to isolate it. And then I'm going to divide by 3y squared. So I end up with dy dx equals 2x minus 2 over 3y squared. There's my derivative. So you're like, oh, this is pretty easy. Now let's look at 3. Now 3, I have something going on here. I have a term here which is a power rule. This is the product rule. This is f and g. So we can do the first term, and I know it's 2x dx. But I still got to do my f and g's over here. And I want to show you, when you do this, make sure you do your dx's and dy's in there. So my f is x, my g is y. So f prime is going to be 1 dx, or just plain old dx. G prime is going to be 1 dy, or just plain old dy. So when I go and put this in here and do the quote product rule, it's going to be f prime g plus f g prime, and just put the dx behind. So f prime g is y dx plus f g prime x dy. So that goes with the xy there, and the derivative of 5 is 0. Okay, now go through and divide everything by dx. So I can say thanks for playing, thanks for playing. So I have 2x plus y plus x dy dx equals 0. Alright, now I've got to solve for dy dx. So I'm going to leave this on this side and move those other two over there. So I have x dy dx equals negative 2x minus y. Alright? And divide by x, so I have dy dx equals negative 2x minus y all over x. And there's my derivative. Okay, I'm going to stop this video, and I'm going to do another video with 3 more other complicated ones, but this will be the first one on the implicit functions.